Hello everyone, this is Ambus Dixit and my registration number is CS17 and today I've been given a task to implement merge sort in C++. So basically what I'm trying to do here is I'm trying to illustrate merge sort's concept with the help of this array. Now merge sort basically depends on the technique known as divide and conquer. Now what that means is we are going to divide each array into half and we are going to split the array into two parts and we are going to merge it after we get single elements. What I mean to say is, first of all, whatever array we get, we find the midpoint of it, and we are gonna split it into two. Now, next, what we are gonna do is, the first half is again gonna it's again gonna get split into two, and the second half is again gonna get split into two. Same process happens until and unless we get a single element. Now, from here, what happens is, now we are gonna merge. Now, as the name says, it's gonna merge in the same way as it's got splitted up. So but the only difference being is we are gonna swap the elements and we are gonna compare it in each time and we are gonna sort it while merging it. That's why the name goes as merge sort. Now as you can see, 14 and 13 or 33 are already sorted, so it just got merged up. 27 and 10, it got swapped and it got merged up. Similarly in the rest of it. And now what we are going to do is we are going to merge again these 2 and 2 elements into 4 elements and again that whole into this array. Now with the help of this, I'm just going to show you the code, how it goes, as how basically this merge sort is working in here. Now what we're going to do is we are going to declare a merge1 as a new function. Now merge sort, we are going to sort it. Now we are going to compare that whether low is less than high or not. If this is not the case, then the program would malfunction. That's why we are going to consider this case. Now mid is equals to low plus high by 2. What basically we are doing over here is we are finding the mid value. Now we are going to pass this a, low and mid merge sort. We are going to call it recursively. Here you can see the recursion: a mid plus 1 comma high merge 1 a low high mid. What this thing is going to do is it's going to sort the array. Now merge 1. Here as you can see, what we are going to do is we are going to initialize I, j, k and an array of 10 elements. Now we initialize I as low, initialize k as low and initialize j as mid plus 1. Now this sorting algorithm uses another array and it's not the same point, it's not in the same array, and it stores all the elements into next array and again sends it back into the same array. That is why we have to use this k variable. Now what we are going to do is we are going to compare whether I is less than mid and j is less than high. If so, we are going to check if a of I is less than a of j. If so, we are going to swap the elements. Else if c of k is equals to a of j, a of j, we are gonna assign a of j to c of k, and we are always gonna increment I and k. I in case of first array and j in case of second one. While if I is less than equals to mid, what if I is less than equals to mid? What we are going to do is we are going to store ai in ck and increment k plus plus and I plus plus. Right now what we are trying to do is we are forming a second array and sorting it up in the process. Now while j is less than equals to high, a of j gets again stored into c of k and k gets incremented and j gets incremented. For I is equals to low, I is less than k, I plus plus, c of I is again gets stored into k of I. This technique is very useful and it helps in sorting of an array with minimum time complexity, and it's the best sorting function. As you can see, this is just the main function. We are going to call this function over here. We are going to pass arguments a, 0 and 4, and this would get sorted. And now again for displaying the result, we are going to use this cout statement. Now without further ado, I'll just show you the output. Now enter the elements one by one. What I'm going to do is, now as you can see, the sorted array is 1 2 3 4 5. What I entered is 1 2 3 5 4. As you can see, it got sorted up. Now this way I can just show you one more example. I'll just put an decrementing array. As you can see, 1 2 3 5 6. Thank you very much.